So this is the shorthand notation for the derivative of y, and it's assumed with respect to x. So if we go through term by term and find the derivative, this is just 2x. The derivative of this term needs the product rule because this is a function of x, and then y is some sort of function of x that we don't know. So it's the derivative of the first function with the second kept the same, plus the first function kept the same times the derivative of the second. The derivative of y with respect to x is not known explicitly, so we write y prime here. And then watch out here, the derivative of 5y squared isn't just 10y, because you need to use the chain rule. The derivative of the innermost function is something different. It's something meaningfully different, so we need y prime there. And the derivative of a constant is 0. So that's our derivative. We just need to solve for y prime, and then we'll have the first part of this problem. What you should do is get the y prime terms by themselves. Okay, it's going to be easier for me to type it, actually, because everything's the first power. So this is 6xy prime minus 10y prime, and that's going to equal negative 2x minus 6y, because I subtracted those from both sides. Okay, and then we're still trying to get y prime by itself, so I'm going to factor out a y prime. And then I'm going to divide both sides by that 6x minus 10y. So when I do that, I get y prime is negative 2x minus 6y all over 6x minus 10y. And to make your life easier, factor out a 2 from the top and the bottom. And I'll do a negative 2 to turn all these positive. This is negative 2x plus 3 when I factor out a negative 2. And then on the bottom, that's 3x minus 5y. So the negatives cancel, so you got negative, parentheses, x plus 3y, all over 3x minus 5y. Okay, so for the harder part of this problem, we need y prime prime. So the second derivative, we need to take a derivative of this with respect to x. So it's two different functions of x being divided from one another, so that means we need the quotient rule. So the quotient rule says it's the derivative of the top function. Remember, you need implicit differentiation there because we don't know what y is with respect to x. So this is the derivative of the top function times the bottom function kept the same. And then we subtract that by the top function kept the same. Oh, I'm using the longer version. I should have been doing this. That would have saved me probably some coefficients, but I've already started doing this, so I'll stick with it. Derivative of the top function times the bottom kept the same, minus the top function kept the same because we're doing the quotient rule, times the derivative of the bottom. So term by term, that's 6 minus 10y prime in the bottom. And that's all over the bottom function squared. Okay. So that's the derivative. There's lots of algebra we can do to clean up. And we don't want to have our second derivative in terms of our first derivative. So what we can do is we can plug what our first derivative is in everywhere we see y prime. But let me clean up algebraically first. We'll multiply these parentheses. So I multiply those parentheses together. Let me double check. Plus 20y minus 36xy prime plus. Okay, and then here I got a subtraction sign, so I want to protect whatever this multiplication is in parentheses. So it's negative 12x plus 20xy prime minus 36y plus 60y prime. Kind of ran out of room on the whiteboard, but it's all over this denominator. So I'm going to distribute that negative sign and combine like terms. So typing is probably easier again. Got negative 12x plus 20y minus 36xy prime plus 60y prime. So it's minus a negative, so that's plus 12x minus 20xy prime minus 30. I can't read my handwriting. What was this? That's 36y plus 60y y prime. And the bottom's still the same. I'm going to save myself some writing there. The bottom is all this stuff. Okay, so let's clean up. Let's do the plain old x terms. Oh, I dropped an x here. Sorry about that. Negative 12x plus 12x makes 0. So let's do the y terms. 20y minus 36y, that makes negative 16y. Let's do the xy prime terms. We got negative 36xy prime. And then this term, so subtract the 20xy prime, so that brings us further back into the negatives. We're at 56xy prime. And then the y prime terms, we got 60 plus 60. Oh, and I've got a wrong sign here. I'm glad I'm double checking my work while I do it, because look, I'm supposed to distribute a minus sign here. Oh no, and I didn't distribute it here either. Look, this is minus a negative 12x, so that makes plus. Minus a positive 20xy, so that's right. Minus a negative 36, so that should be plus. Minus 60y, so that should be minus. So the y prime terms cancel, and then my coefficient here is wrong because negative 36xy prime. Is that wrong? No, I had that part right. My y terms did not perfectly cancel. I got 20y plus 36y, so that should be 56y. Okay, so with that correction, the y prime terms cancel out. I think I've done everything. They've all canceled nicely here. And then this is all over 6x minus 10y squared. So in the bottom we can do some factoring. In the top we can too. Because look in the bottom, you can factor out a 2 from everything. So keep the top the same. In the bottom we can factor out a 2, so that's 3x minus 5y. That's all being squared. So if you're squaring that, that makes a 4 on the bottom. I think you can divide the top and the bottom by 4. Because look, in the numerator up here, you can factor out a 56. We got y minus xy prime left over. And the denominator, that's 2. That's going to be squared, so that's 4 3x minus 5y squared. So 56 divided by 4 makes 14. So that just saves us some work down the road. So this is going to be 14y minus xy prime. It's all over 3x minus 5y squared. Okay. What was I doing next? Yeah, so now we got to put everything in terms of x and y. So we got to substitute what y prime is. It's negative x plus 3y over 3x minus 5y. So in here, it's going to be a double-decker fraction, which is always ugly. Here, let me just copy this. Assuming I've got that part right. This video is going to be really sad when I delete it if I have it wrong, if I miss something again. Trying to clear the whiteboard. Probably painful to watch, huh? Okay, that's good enough. So let's put that back in. Oh, I deleted what y prime was. Y prime, let's see if I can memorize it. Shoot, I don't remember. I'm going to have to go back in the video, so I'll pause this. Okay, so I recovered what we had. So we got 14y minus x times y prime is negative x plus 3y over 3x minus 5y. A brutal looking fraction. It's all over 3x minus 5y squared. So the way I'd handle this is that, no, that's not going to work. Oh. Okay, so let's distribute that 14. And while I'm at it, I'm going to do x. This is x over 1 times this, so that's going to be an x in the numerator. It's minus a negative, so it's going to change this to a plus. That's 14x, x plus 3y. It's all over 3x minus 5y. I'll divide by 3x minus 5y squared. I think the only thing to do is to get common denominators. So we can get common denominators here if we multiply the top and the bottom by 3x minus 5y. So now we got common denominators, so now we can add the numerators. I'll distribute this 14y and this 14x to everything. It's 42xy minus, my brain's too fuzzy to do that in my head right now, 70y squared plus 14x squared plus 1428, 42 xy all over 3x minus 5y, and that's just the numerator. The denominator is still 3x minus 5y squared. Okay, still need more whiteboard space. Let's see what we can do here. Okay, so if we're dividing by this, that's the same thing as rewriting it as this top fraction. Divide by this bottom 3x minus 5y squared. So when you divide something, you could flip and multiply. So let's change this to multiplication. And I'm doing 1 over 3x minus 5y squared. So if I multiply the straight across the numerator, straight across the denominator, we're going to get 3x minus 5y to the third on the bottom. And up top, we can combine these to make 84x y minus 70y squared plus 14x squared. So you could factor out from the numerator, they all divisible by 14. Yeah, I think so. Yeah, you can take out a 14, and that's it. So that's 6xy minus 5y squared plus x squared in the numerator, and then same thing in the denominator.